Hello everyone, I'm Yogender Singh. I belong to Behror in Rajasthan. I completed my graduation from University of Delhi and currently I'm pursuing Master in Mathematics at IIT Jodhpur. Today I will explain the topic differential equation. So let's see. So today we will topic differential equation. So then we what is the differential equation, type of differential equation, order and the degree of differential equation, formation and the solution of the differential equation. Okay, and in last we see method to solve differential equation. So to first we see what is equation. So in previous class we know that x plus y is equal to 0 is the two variable linear equation. X square plus 2x plus 5 is equal to 0. This is quadratic equation, and cos x minus sin x is equal to 0. This is trigonometric equation. Similarly, there is differential equation like that. So y is equal to x square plus 2x plus 5. In this equation, we know that y is a function of x. So y is dependent variable and x is independent variable. This term used in differential equation. So that's why we see that. Okay. Now we see what is definition of differential equation. An equation involving derivative of dependent variable with respect to independent variable are called differential equation. Those equation involving derivative of dependent variable with respect to independent variable are called differential equation. We see example like d square by dx square plus dy by dx is equal to 0, or second example we see that d cube y upon dx cube plus d square y upon dx square ka whole square plus y, like that, are called differential equation. Now we see type of differential equation. There are mainly two types of differential equation. First is ordinary differential equation and second one is partial differential equation. In ordinary differential equation, there is only one independent variable, like dy by dx plus y is equal to 0. In this equation, we clearly see that there is only one independent variable, which is x, are called ordinary differential equation. Or I give one more example: d square by dx square plus dy by dx the whole square plus y is equal to 0. This is also ordinary differential. There is only one independent variable. If there is more than one independent variable, then we call it is partial differential equation. So we see definition: equation involving more than one independent variable are called partial differential equation. Like z is the function of x comma y. So we write del z by del x plus del z by del y is equal to 0. In ordinary differential equation, these terms are called total derivatives term, and in partial differential, partial derivative terms are present. Okay, del z by del x, partial derivative of z with respect to x. Del z by del y, partial derivative of z with respect to y. Or one more we see like del square z y upon del x square plus del square z by del y square. In our course, there is only ordinary differential equation. We did not discuss partial differential equation. So if I say differential equation, it means that ordinary differential equation in this course. Okay. Now an important point is that what is the order of differential equation? Order of differential equation is that the order of the highest order term present in the differential equation. In an given equation, the highest order derivative term present are the order of the differential equation. Like I write example first, like dqy upon dx square plus dy upon dx whole 5 plus y is equal to 0. In this differential equation, we clearly see that this is third order derivative, this is first order derivative. Okay, so highest order derivative is third, so we say order is 3. Or we see one more example, d square by dx square whole cube plus dy by dx equal to 0. In this equation, we see that this is second order derivative, this is first order derivative. So the order of differential equation is 2. Second order, highest order derivative is 2. So order of the differential equation is 2. Now we see degree of differential equation. Degree of differential equation is degree of the highest order derivative present in the differential equation. The highest degree of highest order derivative. But differential equation does not contain any fraction term, any sign derivative does not in the sine function, cos function, trigonometry function, inverse trigonometry function, exponential function, log function. So we cannot define degree if derivative present in these functions. So we see example first, dq by dx square to power 2 plus d square by dx square to power 5 plus y is equal to 0. In this differential equation, we see that this is the third order derivative, this is the second order derivative. So highest order derivative is 3. Now we see degree. The degree of the highest order derivative is 2. So degree is equal to 2. Okay. Now see one more example. dy by dx की power 2 by 3 is equal to y. We see that in this equation the derivative degree is fraction, so we cannot define in this case degree. But if we cube both sides, then equation reduce to normal. dy by dx का whole square is equal to y cube. Now there is no any fraction power in the derivative of the derivative, so degree of the differential equation is 2. Here more example, sine dy by dx plus y is equal to 0. In this differential equation, the derivative present in sine angle, so we cannot define. In this case, we cannot define the degree of differential equation. So degree not defined. In this case, degree is not defined. In place of sine, it is also log function, exponential function. Then we cannot define the degree of the differential equation. Note: if degree and order of the differential equation are always positive integers, like 1, 2, 3, not 1 by 2 order, 3 by 2 degree. This is not the order and degree of the differential equation. Order and degree are always in positive integers. Okay, this is the main point. Now see one more question. Y is equal to 1 plus dy by dx plus 1 by 2 factorial d square by dx square plus 1 upon 3 factorial dq by dx cube plus total. When we see this question, this term look like expansion of e to power x. The expansion of e to power x is equal to 1 plus x square upon 2 factorial plus x cube upon 3 factorial plus so on. If we replace x by dy by dx, the question is look like similar. Okay, then we say that y is equal to e to power dy by dx. Okay, but now it is the dy by dx present in exponential function, so we have to remove this function. So take log both side, so ln y is equal to ln e dy by dx. Power come forward, dy by dx ln e. We know that ln e is equal to 1, so ln y is equal to dy by dx. So now we define the degree. So degree is equal to highest order derivative is first order derivative and degree is equal to 1. Okay, this is called degree of the differential equation. Yet we have discussed two topic, order and degree of the differential equation. Now, to move forward, we'll look at one more question. In this question, we see this is the second order derivative and this is the first order derivative. The first order derivative present in the log function. So in or we are not able to remove this function, so degree of this differential equation is not defined. So degree of this differential equation is not defined, but order is equal to highest order derivative is 2, so order is 2. Now we see formation of differential equation. How to form a differential equation? Basically, in any given family of equation, there are arbitrary constant. We have to remove arbitrary constant. If in any given equation there are two arbitrary constant, we have to differentiate 2 times. If there is 3 arbitrary constant, we have to differentiate 3 times and solve these 3 and 4 equation and remove arbitrary constant. It is our main task. So in this given question, y square is equal to 4a plus x plus b. There are two arbitrary constants. A and b are arbitrary constant. A and b are arbitrary constant. So we have to remove it. So first we open the bracket. Y square is equal to 4ax plus 4ab. So now we differentiate with respect to x. So differentiation of y square is equal to 2 into y into dy by dx is equal to differentiation of 4x is equal to 4a and 4ab is equal to 0. Now we cancel out to both sides. So y is equal to dy by dx is equal to 2a. Now we again differentiate with respect to x. Now this is the, we have to apply chain rule because the product of two functions. So first as it is, second curve differentiation plus first curve differentiation of first term, second as it is, constant equal to 0. So we had by dy by dx square plus dy by dx का whole square is equal to 0. This is the our given required differential equation. Okay. Now we do one more question. X into y a e to power x plus b e to power minus x. Here also there are two arbitrary constants. We have to differentiate 2 times. So this is the product of two function. So we have to apply chain rule. So first as it is, second derivative of second term plus first differentiation of first term and second as it is equal to differentiation of a e to power x plus differentiation of b e to power minus x. Okay, again we have to differentiate, we have to apply product rule. So first as it is, differentiation of second term plus differentiation of first term, second as it is, plus differentiation of y is equal to differentiation of a e power x, and again minus e power minus x d e power minus x. Okay, we have to combine this term. Now we obtain this differential equation, and we see that a e power x plus b e power x is equal to x into y. So we write x into y. So this is our required differential equation. Okay, one more question. Y is equal to c into e power x plus b. In this equation, first we look like there are two arbitrary constants, but not. There is only one arbitrary constant. How? We can write y is equal to c into e power x into e power b. And c and e power b is both are constant, so we combine this constant a e power x, where a is equal to c into e power b. Now we differentiate with respect to x, so dy by dx is equal to a into e power x, and a e power x is equal to y, so we can write dy by dx is equal to y. This is our required differential equation. So it is a method to formulate differential equation. Now we see solution of differential equation. When we say it is the solution of this differential equation, y is equal to e power minus 3x is the solution of d square by dx square plus dy by dx minus 6y is equal to 0. If this term satisfy this equation, this differential equation, then we call this is the solution of this differential equation. So we have to differentiate y is equal to e power minus 3x two times, because their second order derivative present, so we have to differentiate two times. So first time we do dy by dx is equal to e power minus 3x derivative is minus 3 e power minus 3x. Again we have to derivative d square by upon dx square is equal to 9 e power minus 3x. Okay, now we put in the differential equation. So in LHS side, we put e power minus 3x, the value of d square by dx square. Now put dy by dx plus dy by dx is equal to minus 3 e power minus 3x minus 6, value of y is equal to e power minus 3x. When we compute this, we get is equal to 0. So LHS is equal to RHS. So it is the solution of this required differential equation. Similarly, we do this question. When we say this is the solution of differential equation, if this y is equal to a cos x plus b sin x satisfy this equation, then we call it is the solution of this differential equation. So we have to y is equal to a cos x plus b sin x. We have to differentiate with respect to x. So minus a sin x plus b cos x. The second order derivative present, so we have to differentiate two times. So dy by dx square is equal to minus a sin x minus b sin x. Now we put value of second order derivative in this equation. Then we say that minus a sin x minus b. So by mistake I write wrong. Dy by dx square is equal to minus a cos x minus b sin x. So I write minus a cos x minus b sin x. And what is the value of y plus a cos x plus b sin x? Cancel out and we get 0. Again LHS equal to RHS. So we say this is the solution of this differential equation. Okay, now we see type of solution. There are two types of solution. First is general solution and another is particular solution. in general solution, arbitrary constant are present. Like I write y is equal to a sin x plus b cos x. In this equation, we see that y is equal to a sin x, b cos x. They are two arbitrary constants. A and b are arbitrary constant. If any solution contain arbitrary constant, then we said it is general solution. If they if we put value of arbitrary constant particularly, then we say it is a particular solution. How to get value of arbitrary constant? And the condition is given in question. We put the condition in question and we get value of arbitrary constant. And suppose we get a is equal to 10 and b is equal to 5. Then we say y is equal to 10 sin x plus 5 cos x. Okay. So this is the particular solution of the given differential equation. These values are obtained from the condition given in the question. We see question. Now see method to solve differential equation. We have to solve first order, first degree differential equation. There are mainly four types of four methods. First is variable separable and reduced to variable separable. Second is homogeneous and reduced to homogeneous method. Third is linear differential equation and reduced to linear differential equation. And last one is exact differential equation or reduced to exact form. There are mainly four types of four method to solve differential equation. Now we see variable separable method. In variable separable method, the differential equation is like dy by dx is equal to fx comma y. This is the function of x and y. So we take in variable separable, we dy by dx, we separate the variable. We g of x into h of y. We separate the variable x and y different. Okay. So dy by upon h of y is equal to g of x into dx. Integrating both sides. If we integrate both sides, integration dy by h of y is equal to integration g of x into dx. This is the general method to solve variable separable questions. There is one question, dy by dx is equal to minus 4x y square. In this question we see that we write dy by dx minus 4x into y square. This is the function of x and this is the function of y. So we clearly dy upon y square we write and minus 4x into dx. Now integrate both sides. So dy by dx y square is equal to integration minus 4x into dx. Integration of 1 upon y square is minus 1 upon y, or minus 4x square upon 2 plus c. We also write constant is here. Okay. And now cancel at 2. Minus 1 upon y is equal to minus 2x square plus c. Okay. Multiply minus both sides. 1 upon y is equal to 2x square minus c. Reciprocal both sides, so we get 1 upon 2x square minus c. This is the required general solution. This is general solution. Solution of this differential equation. If any condition given in the question like y is equal to 1 when x is equal to 0, like this condition, so we put value of y is equal to 1 and x is equal to 0. So we get 1 is equal to minus 1 upon c, c is equal to minus 1. We put the value minus in the general solution and we get the particular solution. So y is equal to 1 upon 2 a to power x plus 1. This is the particular solution of the differential equation. Particular solution. Okay. So we end up here. So thank you so much for watching this video.